I'm happy to introduce you to our Blue Lake wastewater treatment facility, which treats about 28 million gallons of wastewater a day, serves 285,000 residents and 27 communities. Right now you're standing in what we call the digester building, which is part of our solids handling complex. And an interesting fact about this building, which was completed this year, is that it recovers methane biogas, which we can then substitute for natural gas, and we save about $500,000 a year on energy due to that. So we're kind of excited about the pluses of this new facility. Blue Lake, along with our other facility, Met Council facility that's on the Minnesota River, the Seneca plant, which is in Egan, have been reducing their phosphorus discharges since 2000 quite significantly. In fact, between them, they've reduced their phosphorus by over 50% in terms of what's going into the Minnesota River. So that leads us to why MPCA wanted to talk to you today about that good news. So with that, I'm going to turn it over now to John Linkstein, who's the commissioner with the Minnesota Pollution Control Agency.
Morning, and thank you. It's a great day for the river. One of the things that we know is it takes a long time and a lot of cumulative effects to impair water quality, but it also takes consistent cumulative positive efforts to improve water quality. That's one of the things we're here to thank people for today, especially our partners in wastewater treatment. We have a significant number of plants up and down the Minnesota River, its tributaries that contribute water to the Minnesota River, who've taken cumulative positive actions to reduce phosphorus loads in the Minnesota River watershed. And it's that kind of partnership that allows us to celebrate improvements in water quality, like you'll hear a little bit more from folks today about that. We know that once upon a time, the Minnesota River was looked upon as one of the worst rivers in the nation, and this is one of the most serious efforts that our agency, the Pollution Control Agency, has put toward improvement of water quality. And we implemented in the late 90s a trading program that allowed wastewater treatment plants to increase their flexibility as to how they might gain better control of phosphorus discharges. And what that's done is improved dissolved oxygen in the water column, and that dissolved oxygen is the base of all the aquatic life. The critters, the fish, the birds that use the river, those are all come from having oxygenated water. And so because of the cumulative efforts of our partners in wastewater treatment, we did some work this summer that verified that there's an improvement in dissolved oxygen levels, and our staff, Glenn Scuda, is here to talk about that a little later. But mostly we're here at the Blue Lake wastewater treatment plant because this is one of the plants that's put a lot of efforts, a lot of technology in place to reduce their phosphorus loads. So we want to thank the Metropolitan Council, who's responsible for the wastewater treatment across the metropolitan area, and I'd like to introduce the Met Council Executive Director, Susan Haig.
Thank you all for coming out on a cold and snowy day. It really is gratifying to see that you're covering what is really an important message, is that when we work together, we can really make improvement in the quality of our water and really the quality of our life here in Minnesota. You know, for a lot of people, wastewater treatment is something that they don't pay too much attention to. It's sort of out of sight, out of mind. But that is not our experience. At the Met Council, our Environmental Services Division really is always thinking hard about how we can help to improve the public health, the quality of our rivers, and this is a great example here. You know, you're standing in a place kind of where the magic of science happens. I'm not a scientist, so it all seems like a little bit like magic to me. And I'm glad we have some of the scientists here who can really answer more of your detailed questions. But our work at the Met Council in wastewater treatment is both about improving the quality of our rivers and the quality of the health of our citizens, but it's also making sure we're doing that in a cost-effective way and at a good price for all of our ratepayers, because it's a system that really is paid for by the people who use it. And we're very proud that our rates for wastewater treatment are some of the very most cost-effective in the country. We're actually 40% lower than the average in the country, and it's because we have a regional connected system. And I think it's really one of the great accomplishments of this region and our Met Council that we do this work. We actually, we have 7 treatment plants. This is one of 7. We actually work with 800 industrial customers to help them think about how they can reduce their wastewater that comes to us for treatment. So we're thinking way upstream about this, as well as what we do to the wastewater when it comes into plants like this. We're treating about 260 million gallons of wastewater every day. So the volume and the way in which we impact the community is something that goes on and on and on, and that's a good thing. I think it's really quite a story to see how the wastewater comes in and the quality as it comes out. And so I hope that many of you will come on the tour today so you get a chance to see that. We've made a big investment in this plant here at Blue Lake. We've put in about $120 million into this plant. It's actually one of the very most advanced plants in the country and one of the most energy efficient plants in the country. And it's so great to see the results, that it really is making a difference for the river, and that it's making a difference for everyone in our region. It's a remarkable story. Rivers that are going to support aquatic life, recreational activities, really have so much to do with the health of our economy and the health of the region. They're great assets for our community, and we really have to see them as the precious resources that they are. We have been investing in plant upgrades, in new ways of doing treatment, in more energy efficient ways to do our work. So we're also making sure that we can build a great system for the future. We see the MPCA really as our partner. You know, they have to help us think through how we do this work. So it's great for them to recognize all the great work that we have done over many years. Well, one of the ways, you know, that the phosphorus enters into our streams and rivers is also through agricultural runoff. And so there's lots of partners that need to be working on this issue. It's not just us at the Met Council. We're part of many people who have to have this as a priority. And I know we have a lot of challenge left, that this isn't the end of the story, but what it shows is that when we work together, when we have a common goal, when we set priorities about how we do our work, we can really make terrific things happen. And now I'm going to ask Glenn Skuta to come up, who is a scientist and the expert who can really go into much more detail. So thank you very much.
Here's the backstory on what we're celebrating today. About 30 years ago, we found that the lowest 20 miles of the Minnesota River was oxygen starved at times when temperatures are high and the flow of the river is low. So on the map here, that red area, that's the lowest 20 miles from where the Minnesota River meets the Mississippi up to about Valley Fair, just a little bit upstream from here. At dry, low precipitation, low river flow times like this, wastewater treatment plant discharges are primarily the main potential impact on a river, because at that time their discharge makes up an appreciable amount of the flow of the river, and we don't have other pollutants coming into the river from overland because it's not raining. So like on a day like today, where the flow of the river is about 600 cubic feet per second, wastewater is more than 1/10 of the flow in this stretch of the river. So once those impacts were seen back in the early 80s, treatment plants started improving their treatment, but it would take a lot of time to make all of those upgrades, and improvements in technology would take time to come along as well. In the early 1990s, the Pollution Control Agency designated this lower 20-mile stretch of the Minnesota River as impaired due to the violations of the low dissolved oxygen standard on the river. That standard is set to protect fish and aquatic life. They need air to breathe, air that's in the water just like we breathe the air around us. About 10 years ago, a more aggressive cleanup plan for the river was developed, focusing on reducing phosphorus discharges from wastewater treatment plants. Phosphorus limits in permits are important because they control the phosphorus level, and when we control the phosphorus level, we control the amount of algae in the river, and thus the amount of oxygen in the water that is used up when those algae die. The cleanup plan at that time, and still today, was really quite innovative, and it took a lot of cooperation to develop and to execute it. Phosphorus treatment for river discharges was a pretty new thing at that time, but the Met Council and cities like Mankato stepped up to do phosphorus removal at their plants. Met Council also aerates their discharge at the Seneca treatment plant downstream from here during low flow times to help increase oxygen levels in the river. We also put in a pollutant trading portion of the permit at that time to allow dischargers to trade the amount of phosphorus levels that they treat to do this phosphorus control in the most economical way possible. Plants also upstream started controlling when they discharge their wastewater because not all plants discharge their wastewater continuously, and when they, the treatment plants that have ponds where they can control their discharge, if they hold their discharge back at these low flow times, again, there's less phosphorus going into the river at the critical flow period. And then we had about a dozen under-sewered communities upstream that did not have very good wastewater treatment at all, and they began upgrading and have greatly improved their wastewater discharges. So we had over 100 communities in the Minnesota River Basin and industrial discharges that improved their wastewater treatment and their discharge. So, did it work? Well, a couple months ago, just in August here, we had, of course, a very hot, dry period given the drought that we're in. The river was running about half its normal flow for this time of year. It was flowing at about 800 cubic feet per second at the lowest flow while we were out monitoring for 3 weeks in August. At that time also, the air temperature and the water temperature subsequently was quite high, and the river was under a pretty stressed condition. So what did we find? We found no violations of the water quality standard. The river had sufficient oxygen to support fish and aquatic life well at this time. And we found lower levels of phosphorus and chlorophyll compared to past surveys done under similar conditions. So this is great news for the river, particularly at those low flow, high temperature times that are the critical time period for oxygen levels in the river. And this really is something to celebrate. Now, if the drought persists and we get even lower flows next year, we will survey again to see if current efforts are protecting the river even down to the goal level of at 350 cubic feet per second. If so, if the oxygen levels are still good at those very, very low flows, we'll be able to remove the designation of the river as impaired. As was mentioned, other problems with the river certainly do persist, like high levels of sediment caused by excessive drainage in the basin, endocrine active compounds in our waters, those types of things. Other cleanup plans have been proposed for the river, its tributaries, and for downstream places like Lake Pepin. So there is still work to be done to improve the river, further work to be done by those on the land and by wastewater treatment plants too. But it's important to celebrate successes like the one that we have today.